All right, so we are, oh, I got a new way to write on the board. This is the way I used to do it when I was teaching math. And this has a lot more bells and whistles and stuff, so we'll try this out, see how it goes. All right, so we're going to go over some homework, right? And I know we want to do that last one, that 39. Let's pick one of the other ones. It's either 31, 33, 35, or 37. We'll definitely do 39. Is there one in there that you want to try besides 39? Somebody speak up. Let me know.
Mr. Hammer, come here.
Yeah. What's up?
I'm here.
Oh. Is somebody saying they're here? Is that what they're doing?
Yeah,
who was that? Tell me who it is.
It's Joe.
Joe. Okay. All right, gotcha. Because I can't, right now I can't see anybody's names on there, so I don't know who's on there or not. So let me just make Joe present. There he is. So which one are we doing? Are we just going to do 39 and that's it? If I don't hear from you, that's all we're going to do.
That's fine.
Okay. So 39. So we are verifying if these are inverses or not, right? So let's see what we got. We got f of x equals 2x plus 3 over, hardest part about this is just working with the fractions, x plus 4. Okay, and then the inverse is going to be 4x minus 3 over 2 minus x. All right, so what do we do? Well, let's write that thing down. Remember, this is a different color. Remember that little thing to verify if these are inverses or not? So we go f of the inverse, and that should equal x. And then we're also going to look at this. We're going to go the inverse of the function, and we're going to see if that's equal to x. So what are we going to do? Let's start with this one. It doesn't matter which one you start with, but I always like to do this. I like to take the inverse and put it in to the function. So that means, let me scooch this up just a little bit right there. Okay, so watch. I want to take this whole thing and I want to put it, now in this one, we're going to put it right there, and we're also going to put it, whoops, right there, in for that x. So we're actually putting it in two different places. So when we did the examples in class, I think we only put it in for like one of the x's. But every time there's an x here, we're going to take that inverse function and we're going to put it in for that. And then for the other one, for this one right here, we're going to go vice versa. We're going to take that whole thing. I'm not going to circle it right now because it's too messy. But we're going to take that whole thing and then put it in for that x. We're going to take that whole thing and we're going to put it in for that x. And then we're going to simplify. All right, so let's do this. Let's go different color. Let's go yellow. All right, so let's do this first one right here. So we're going to go 2 and then a big old parentheses. And what are we putting in for that x? This whole thing, this whole big old fraction. It's kind of gross, but take our time. We can work this thing out. 2 minus x. Oops. Should put that big old parentheses like that. Okay, so there's the 2x right there. We've got to fill in all the other stuff as well. So we're going to put a plus 3, and this is over x plus 4. We're not going to put just an x. We're going to put that inverse function in for that x. So we are going to go 4x minus 3 over 2 minus x. If you want to put that in parentheses, you can. You don't really need to. You did on this one because it was being multiplied by a 2. On this one, we can just put minus x. Now watch what I'm going to do. I'm going to put x over 1. Is that all right? Since we have a fraction here, we need a denominator, so that might make it a little bit easier. So let's work this thing out. So this is what we're going to do. We're going to work this whole mess out. Let's multiply everything through here. Let me just double check my notes just to make sure. Yep, I did that. So what we're going to do, remember this is 2x over 1, or not 2x, just 2 over 1, and we're going to take that 2.
Mr. Hammer?
Yo.
What about the plus 4?
Yeah, what about that plus 4? I forgot all about that. Why, let's see, why did I put minus x here? Well, that was silly. Good call. Thanks for stopping me. Why I put minus x here? Because it's x plus 4, right? So there's our x, and then we got to put a plus 4. Yeah, I must have been looking over here or something. That's probably what I was doing. I was probably looking here. But you're absolutely right. You got to put that in for this. So it's x plus 4. Thanks for stopping me on that. We're still going to put it over 1. All right, so now let's go ahead and multiply this through. If anybody else sees a mistake I make, please point it out to me, because I've been known to make mistakes once or twice. So, all right, so we're going to take a 2. We're going to multiply it by this parentheses. So let's do that. We got an 8x minus 6 over, and this is just times 1 because it's 2 over 1. So it's just 2 minus x. And then it's supposed to be a 6. And then we put a plus 3. I'm going to put that over 1. And we're going to work that out in just a minute. Let's do the bottom. So now we got to do this thing right here. Now, if you look at this, you're going to add fractions right here. Now, Mr. Rao taught you something where you could actually cross multiply and then put it over top of that same fraction. But I'm going to show you like the old-fashioned way to do it. Let's do this kind of a red color. So what I'm going to do is when you add fractions, you need a common denominator. So you got a 2 minus x right there. So what you're going to do, and this will work out exactly the same way as if you did that cross multiply thing. All right. So that's what our common denominator is going to be. It's going to be 2 minus x. So what we're going to do is we're going to write this whole thing over 2 minus x. And now we're going to just try to simplify the top as much as we can. So I'm just going to put, we need to make this a little bit longer. I'm going to put a 4x minus 3 right here, and then plus. Now I'm going to take that 4 and distribute it through here. So that's going to be an 8 minus 4x. I think I did everything right there, did I? So we're going to do the same thing up here. So we're going to put a big old fraction bar thing right there. That's this one. And then we need to find a common denominator with this as well. So we're going to basically do the same thing. So we are going to multiply by 2 minus x here. We're going to multiply this by 2 minus x, and we're going to see what we get. And so my denominator on this one is going to be 2 minus x. And now we figure out what the top is. We got an 8x minus 6 right now. And then this is plus 3, and we distribute through here. So that's going to be a plus 6 minus a 3x. Make this bar a little bit bigger so it all fits. That really was the hardest part of this whole problem. Okay, was finding common denominator. And again, Mr. Rao showed you how you could cross multiply. I told somebody the other day, that's the first time when I was sitting in Mr. Rao's class and he showed cross multiplication here. I always taught for years and years that you could not cross multiply when you have addition or subtraction. You can only do it when there's an equal sign in here. But it's a little bit of a different cross multiply. So you can multiply this together and then this together. I think add all those up, put it over this denominator. I think that's what he did. But I'm going to do it the old way. All right, I'm just going to find a common denominator, multiply the numerator by the same thing, because really you're allowed to do this, because what's this stuff in red? It's just 1, isn't it? Anything divided by itself is just a 1. So you're allowed to do that. It's perfectly fine. All right, that's how we find common denominators. All right, let's keep going. And let's put a little fraction bar right here. Our common denominator to this is also 2 minus x. And then we just, I'm just going to write all this out. We'll simplify it in the next step because we got to simplify a couple things in that step. So we might as well just do it all in the same step. That's minus 4x. I kind of made that a little sloppy. Okay, so let's push this up a little bit. Now, here's the thing. This actually works out pretty easy. You see this denominator here and this denominator here? Technically, when you divide something, you multiply by the reciprocal. So what we're going to do, instead of dividing by this, we're going to multiply by the reciprocal, which means this is now going to go on top because that's the reciprocal. This is going to go on the bottom. So the 2 minus x's actually cancel out right here. Do you want to see that whole process, or you just believe me? I don't know. Somebody talk to me. Chris, you're kind of into it. What do you think? Should I show that step or should I just skip it?
Just show the steps so we all
Show
know
the
what we're
step.
walking through.
All right, might as well. So we got, and let's simplify the top right now. What's going to happen here? And I'm actually, let's not even put the 8x right there, because let's simplify the top. So this and this add up to 0. 8x minus 3x is 5x. That's over 2 minus x. Let's simplify the bottom right here. Let's see what we got. 4x minus 4x, so that cancels out with that, adds up to 0. Negative 3 plus 8 is 5, just a regular old 5. And that's over 2 minus x. So that wasn't hard. That was easy step. Here's the thing that a lot of people get confused on. Again, when you divide something, you multiply by the reciprocal. Everybody remember that? So what if I had like 1/2 divided by, I don't know, 3/5? Do you remember doing this in elementary school? You never really do division, do you? You always turn division into multiplication. So this is what we did back in elementary school. We took 1/2. Instead of dividing by 3/5, we multiplied by the reciprocal. The reciprocal means you just flip the fraction. So you multiply by 5/3, multiply across, that's 5/6. That's how you did that, okay? We're basically going to do the same thing right here. So we're going to take the top, we're going to divide it by the bottom. So this is the numerator to our big fraction, and this is our denominator. So we're going to keep the numerator the same. Let's get rid of those circles. So we keep this the same. Instead of dividing, we multiply by this reciprocal. So what's the reciprocal of this? You just flip the fraction. So you get a 2 minus x on the top, and you get a 5 on the bottom. Everybody with me on that? If you're lost, let me know. Okay, I can backtrack a little bit here. Everybody's good? All right, I'll take your word for it, or your lack of word for it. So what do we have here? The 2x and the 2x cancel, or not, it's not 2x, it's 2 minus x. The 2 minus x and the 2 minus x cancel out. And what do you have? You got 5x on the top, you got a 5 on the bottom, and check this out. 5's cancel. What are we left with? We're left with x, and we're halfway done. So we've done the first half of it, okay? We verified, let me go up here. So we did this part right here. So we verified that this was equal to x. All right, that's what we did right there. All right, so let's do this. Copy. I'm going to copy all that. Copy. And scooch down. And paste it. There we go. And let's get rid of the rid of this stuff. That little arrow thing. Isn't this a cool little program? All right. I guess nobody else is as impressed with it as I am, but that's all right. Let's see what we want to do. Let's change colors. Okay, so now we want to go the other way. Let's go to this nice orange color. If I can grab it. Where is it? There it is. So now what we're going to do that inverse of a function. Oh, yeah.
I gotta go.
You got to go. Who's you? I can't see who it is.
Jonah.
Jonah. Okay. You got to go? All right. Well, I'm recording this.
Yeah.
So what you can do is you can go on Teams. I'm going to put the link to the YouTube video. It'll probably be ready maybe a half hour after class is over. And I'll put it on the Teams, and you can click on it, and you can watch the rest of the video so you won't miss anything. Okay?
All right.
All right. Thanks for letting me know.
Bye.
See ya. All right. So everybody else good? So this is what we're going to try to do now. So this time, what are we doing? We're taking this function and we're putting it into the inverse. So this time we're taking this stuff, and the math is going to be very, very similar. And we're going to put it in for that x, and then we're going to put it in for that x right there. So I can go kind of quick now. So let's go blue. All right. So let's put this stuff in for here. So we've got 4 times x, which is this stuff. I'm going to go a little faster since we've already explained a lot of this. And then x plus 4. Make sure I write all this stuff down right. Over. And then we're going to put this in for this bottom x. So we're going to put 2 minus, and I'm going to put a big parentheses. I'm going to put 2x plus 3. And then I'm going to put x plus 4. Okay. All right, so let's go through this and do it. Let's multiply everything by this 4. So I get 8x plus 12 over, now this is over 1, so I'm just multiplying 1 by the denominator, so that stays x plus 4. But then I got to do that minus 3 eventually. We'll do that in the next step. All right, over, do this. Now this 2 is not being multiplied by this stuff, is it? Okay, you're actually subtracting this stuff from the 2, but you do have to distribute that negative. That negative has got to be distributed through here. So it's like a -1 outside of this. So we're going to put the 2 right here. And then we're going to put, let's put this over 1. And then let me check what I did just to make sure that I do this right and I don't mess it up, because this is a little bit confusing. Where's the one with the negative? 2 minus, there we go. Yep. All right, so what we're going to do is distribute it. Now, you only distribute it through the top one. You're not going to distribute it through the bottom one. It's just -1 over +1. So you multiply it by the top. So that's minus 2x, and then it's minus 3. Okay, that's a little tricky. Even though the math isn't hard, it's a little tricky to understand that. And this is, let's see. How do I want to do this? What did I do? It looks like I multiplied by 2. Why did I do that? Minus 2x. Oh, I see what I did. I see what I did. So this is over... just this bit right there is over x plus 4, all right? So basically, this is what we have. So we're going to have to find a common denominator with all of these. So let's go through that again. That's the hardest part of this. So I don't know, let's just pick a different color, green. All right, so let's find a common denominator. So my denominator here is 1, and this one is x plus 4, so I multiply this by x plus 4. I multiply that by x plus 4. Same thing here. I got to multiply this by x plus 4 to get the same denominator, and I multiply the top by x plus 4. All right, I'm going to put parentheses around that one. All right, so let's see what we get. Let's push this up a little bit, and let's go back to blue. Grab it, there you go. All right, so what do we get on the top? We have 8x plus 12. Okay, minus, this is a -3, so we have to distribute that -3 through this. So it's -3x, and then it's going to be minus 3 times 4, which is 12. See that? The negative goes through both of these. It's like a -3. -3x, -3 times 4, it's -12. And that's all over our common denominator, which is x plus 4. Let's do the same thing to the bottom. So right here, this 2 is being distributed by this. So we get a 2x plus 8. And then we got a minus 2x minus 3. And this is all over x plus 4, because that's our common denominator right there. Now, I will skip that step that we did earlier, okay? If you look at this, you're taking this and you're dividing it by this denominator. So you're taking the numerator, which is this whole thing, dividing it by the denominator. So really, look what happens. That goes away. You might hear some kind of background noise. It's my computer and the fan. I just got this computer and the fan's really loud. And I noticed on the other video that it picked up on the sound, but kind of weird. All right, so let's go through this. So I actually canceled those out. Why did I do that? Well, you could look to here. You could look to here to figure out why I just canceled them out. See how they canceled out here? I could have just looked at this and I knew that they would cancel out. I'd get 5x over 5. So without going through all that work again, I learned something, right? So I can just use this again. So I know that they're going to cancel out. Let's simplify the top. 8x minus 3x is 5x. And then plus 12 minus 12 is 0. These denominators canceled out. Let's simplify the top. 2x minus 2x is 0. And 8 minus 3 is 5. It works exactly the same way. So now you just verified that they are inverses of each other. And that's all they ask you to do. Okay? Wow, it took half the class doing one problem right there. So let's move on. Now, with your homework, just hang on to your homework. Don't take a picture of it and email it to me or Mr. Rowell. Just wait till we get back into school, and I'll collect this homework from you. Okay? All right, hope we're all good with that. Let's move on. Remember yesterday I said that we are going to find what the inverses are on those problems. They gave, let's scooch up to the top again. So they gave you a function and its inverse. What we're going to do is pretend that you didn't even know what that was. We're going to take this and do some work with it. We're going to do a little math with it, and we're going to turn it into this. Okay, so they're not just going to give you two things and you have to figure out if they're inverses or not. You're not just going to verify it. You're actually going to find the inverse of this. It's really not as bad as it may seem. So let's do an example, and I'll just kind of teach you the process through the example. Oops, I'm flipping around to find my lesson that I wrote down so that I make sure I do this right. Okay, there's verify, there's the graph, we already did that. Okay, here we go. So it says find the inverse of this function. So find the inverse of this function, f of x. And they give you the function, and it's pretty easy. It's 2x plus 3. All right, so they start you off pretty easy. So there's the functions, and remember what we're going to do? We're going to take that function, and what we're going to eventually do is figure out what the inverse, okay, of that function actually is. In the previous problems, they told you what the inverse was, but now we got to figure it out on our own. All right, so here's what we do. All right, just through this example, I'll kind of teach the process. F of x is basically, excuse me, f of x is basically the same as y equals. So I'm just going to write this right now. I'm going to write it y equals 2x plus 3. It's just not as cumbersome, right? This is just kind of like fancier than writing y. It's just a lot easier to write this. So here's step one. So step one is to, let's see what I wrote down. What word did I use? Reverse, okay? So I said reverse the x and the y's. Now, I could go through, I watched a video of this math guy. Yes, I watch math videos, especially since I started teaching math again. So this one guy gives a great explanation on why you do this. I'm not going to do that. I'm just going to show you how to do it because I have a feeling that that's probably all you care about anyways, just how to do this thing. So, but he does have a good video out there. If you're interested, I'll let you know at some point the guy's video and you can watch it. So we reverse the x and the y. So what we're going to do here, let's do this in a different color since we're doing something a little different here. Let's go to orangey color. So what we're going to do is reverse the x and the y. So you're going to exchange, okay? You're just going to interchange the x's and the y's. So instead of y equals 2x plus 3, what do you think we're going to write? We're going to write x equals 2y plus 3. Remember, these are inverses of each other. So we're switching stuff around, all right? So we switched the x and the y to find the inverse. That's kind of why we did this, because we're trying to find an inverse. So we switched the x and the y around. So what we're going to do now, step 2, let's write this in white so we see step 2. So step 2 is we're going to solve for y. All right, so that's what we're going to do. So let's take this, scooch it up just a little bit. Let's take this, x equals 2y plus 3. I'm just rewriting it so far. What I want to do is I want to solve for y. So I want to get this by itself. All right, pretty easy. Now we're going to have it in terms of x. So x is going to be part of our answer. We're not just going to get something that's like y equals 2 or y equals -5. We're actually going to get y. We're going to solve for y in terms of x. That means x is going to be part of our answer. All right, so let's solve for y. So what do? Subtract a 3 from both sides. All right, so how do you subtract a 3 from an x? Well, you don't really do that. You just write x minus 3 equals, that cancels out or adds up to 0, equals 2y. All right, and you can, let's see how I did it. I think I wrote it as a fraction. Yeah, I did. So you divide both sides by 2. All right, so you divide this by 2 and you divide this by 2. I don't like my y being over here on the right hand side, so I'm just going to put it over here, and then I'm going to take this and just put it over there, and I can do that perfectly fine. X over 2, what's a way we can write x over 2? It's a lot better, it's a lot nicer and cleaner to write it 1/2 x. And then we put minus 3 over 2. Well, guess what we just did? We solved for y in terms of x. So what is this thing right here? What is the y equals 1/2 x minus 3 over 2? Well, it's the inverse. We just found the inverse. So let's, oops, where am I going? There we go. So remember up here, we wanted to figure out what the inverse was. Well, guess what? We just found it. All right, so I'll tell you what, let's do this. Let's get rid of that question mark. Let's grab this stuff and let's move it up here. There it is. So this was our function. This is our inverse. And we found it on our own. We didn't have, we weren't waiting for them to tell us what the inverse is and then verify it, but that's what we did. Now, do they say verify it on here? I think they're going to ask you to find the domain and range and graph it. So let's do that. Let me check. They're at least asking you to find the domain and range of the function, and they're asking you to find the domain and range of the inverse right here. So let's do this. I'm going to grab this. I'm going to scooch down to where I was. So this is my inverse, and this was my original function. Show you what I'm going to do here in a sec. So now let's do this. Just let's write it as an inverse instead of just y equals. So we will write the inverse function equals that. So there's my two functions. Let's put these kind of closer to each other. All right, there's my function and there's my inverse function. So what they're going to ask you to do is find the domain and the range of both of these. And you're going to find something that's pretty interesting on this. Well, maybe on the first one you won't really notice it because the domain and range for all of these, for both of these, is exactly the same thing. But let me show you graphically how we can find the domain and range. Oh, watch this. You're going to be so excited about this. Remember I was having trouble drawing those graphs before? Well, watch this. Scooch up a little bit and grab it. Oh, there it is. I'm going to copy it and I'm going to scooch it back down again. I know you're all going to be so excited about this. Check it out. I can just hear the oohs and ahs coming from the virtual world. And we'll scoot it over a little bit. About right there. And let's make it just a little bit bigger. About right there. Okay. So what we're going to do is we're going to graph both of these. And tell you what I'm going to do. Let's change this into a different color. Let's make this like this purpley color, right? So what we're going to do, oh, it's not purple, it's pink. All right, so what we're going to do is we're going to graph both of these. All right, so everybody ready? So here we go. We're going to graph this. So this is pretty easy to graph. You should understand how to graph this stuff. So the y-intercept is 3, so it's 1, 2, 3. Right there. Then the slope is 2 over 1. So rise 2, run 1. We'll do that a couple ways. Let's rise -2 and run -1 as well, just to extend it just a little bit bigger. Okay, watch this. I get this line. This is way cooler than what I had before. Oops. Okay, so watch that. So I can make a nice straight line right through here. I can extend this a little bit like that. Okay, so there, this line is this graph right here. Let's check out this line right here. Let's graph this line. So what in the world is -3.5? Well, let's do this. Let's change the color of it. There we go. So the y-intercept is -3.5, or negative, what is it? 1.5. All right, so that's what we're graphing. You should be able to do this, right? All right, so what we're going to do is we're going to graph this. It's y equals, or f of negative x equals whatever. So where's negative 1.5 on our y-axis? There's negative 1, there's negative 1/2 about right there. So I'm going to put a circle right there, and then the slope is 1/2. So we rise 1. So we're in the halfway spot. So I rise 1 and I run 2 right there. I could keep doing that if I wanted to. Watch. I rise 1 right there and I run 2. See how it all lines up? I like to have 3 points instead of 2 just to kind of verify that. So let's put a line in here and then connect that. And let's stretch this one out a little bit. And you can see by your graph of what if they're inverses of each other or not. Remember, they're mirror images, so they should be mirror images. Let's do a different color that doesn't look like those. Let's do a blue, right? Do you remember the y equals x? We said that they are symmetric. Oops. They're symmetric about the y equals x axis. So that's the y equals x axis. And then I can extend it down to there. Okay. So remember that the blue line is like a it's like a mirror. Okay, and these are flipped. These are exactly on this side of the mirror as this pink line is on this side of the mirror. So they definitely are inverses of each other. So that's pretty important to see. If you look at this, let's not look at that. So that's pretty helpful. But why did we draw the graph? We drew the graph because we wanted to find the domain. I'll tell you what, I'm just going to put D. Is that all right? So I'm going to find the domain and the range of the function. So we'll put f of x right here. Okay, and then we wanted to find the domain and range of the inverse function. All right, so the domain equals and the range equals. And graphing it can really, really help us find it. So the domain means what? What values for x can you put into either one of these functions, into any one of these equations? So let's do the first one, the pink one right here. Where on the x-axis are we allowed to pick a point? Anywhere, because this graph, it keeps on going, doesn't it? If I... let me just do this. So if oops, I didn't want the white color. Let's grab the pink. There we go. So there's an arrow there. There's an arrow there. It's the same exact thing with that orange one. There's an arrow here, and then there's an arrow here. It keeps on going. So along the x-axis, this keeps going forever and ever. So I can go anywhere I want on the x-axis to the left, or to where? To negative infinity. And I can go anywhere on that pink line. I can keep on going all the way to the right on my x-axis. There's always going to be a point that corresponds with it on the y-axis. So the domain for either one of these, for the pink one and for the orange colored one, is going to be from negative infinity to infinity, because it never stops. Okay, it never turns back up. It keeps on going. It keeps on going to the left, and it keeps on going to the right, and it never stops. So our domain right here is going to be from negative infinity. Oops, let's look. There we go. That's a little bit better. To positive infinity. That's what our domain is going to be right here. Let's look at the range for our pink one right here. The range is the up and down. Are there any restrictions on y at all? There were no restrictions on x. Are there any restrictions on y? Is there ever going to come a point where you can't go up any higher? Is there ever going to be a point where you can't go down any further? No, there's not. So guess what? Your range is also negative infinity to infinity. Now, what's cool, you don't see it on this particular problem because the domain and range are exactly the same on both of them, but you're going to find out. And so it's the same thing with the inverse function. Okay, same thing with that orange line is no different. So the domain is negative infinity to infinity, and the range is the same thing. It's negative infinity to infinity. What you're going to find out in the next problem, if we have time to do that, you're going to find out that the domain of one function is going to be exactly the same as the range of its inverse. Same thing with the range. The range of the regular function is always going to be the same as the domain of the inverse function. It's always going to be the same. Now, they're not always going to be negative infinity to infinity, all right? But on this one, it was. They're straight lines, so your domain is infinite and your range is infinite. But you're going to find out on other problems that the domain of one is going to equal the range of the other, and vice versa. The range of one is going to equal the domain of the other, which is actually pretty interesting, I think. All right, so let's do another example, and that should be it. I think I had originally 2 more to do, but they're pretty much the same. Let's see which one I want to do. Yeah, they're kind of the same. And you can look in the book for them if you want. The examples are right in the book. Let's do... example 10. It looks like it's a little easier. We'll grab that graph in a little bit. So let's go back to white. So let's do example 10. So example 10, if you're looking in your book. By the way, I have the book online, so if you do this, check this out. If you go to Teams and you go to, let's see, this one right here. Okay, so when you first get onto your class, you'll see this right before you hit the Meet button. If you go up to Files and you look right here, there it is right there. See, it says Sullivan College Algebra 11th edition. You click on it. I'm not going to click on it because it takes a little ways to load, little time to load. But if you do this, if you wanted to, you could actually download it to your computer. So if you click on it, if you're on a computer, if you click on it, you can go up here and click download, and it'll download the whole entire book to your computer. It's not really that big of a file. You'd think it would be like crazy big, but it's really not that crazy big of a file. So you should have plenty of room to download that. So that's kind of cool if you want to use that. So let's go back to where we were. Now you got to remember though that the numbers on the online edition are a little different than the numbers in the book. So I'm going to give you the numbers from the book. You're going to have to look at the online version and see which problems they are. Okay, the problems are exactly the same. They're just different numbers and they're on different pages. But if you go to the section, you should be able to find which problems you're supposed to be doing. All right, so let's do this. It says find the it says find the domain and range of this and its inverse. Okay. So they're gonna give you a function, and it's a little bit trickier. I'm gonna go pretty quick because time's running out here a little bit, and then I'm gonna give you the inverse. Actually, I'm sorry, I'm not gonna give you the inverse. We have to find what the inverse is. So let's go through this pretty quick here. Again, I'm going to have the video online on YouTube, so if you need to go through it and look at it and slow it down, or stop, pause, think about it, write it down, you can do that. So what we need to do is we need to find the inverse of this function right here. So remember, it's written y equals 2x plus 1 over x minus 1. And what we need to do is we need to solve for x. First of all, we're going to switch the x's and the y's, all right? So I'm going to write, when I said solve for x, I'm sorry. You kind of are. You could solve for x and then switch the y's if you wanted to. But I like to switch the x's and the y's first. Okay, so instead of y, we put x. Instead of 2x, we put 2y plus 1 over y minus 1. So what we are trying to do now is we're trying to solve for y. So the best thing to solve for y, I believe, is to get rid of that denominator, the y minus 1. So I'm going to multiply both sides by y minus 1. If I multiply this side by y minus 1, they cancel each other out. I'm not going to show it, right? Y minus 1, boom, boom, they cancel out. And then you get this right here. So now let's distribute this. So we get xy minus x, and that equals 2y plus 1. At least we got rid of our denominator. That was nice. What are we trying to solve for? We're trying to solve for y. So we're trying to get the y's on the same side. So let's put the y's on the same side. I got a y right here. I'm going to keep it over there. I got a y over here, so I'm going to move it over here to the left. How do I do that? I subtract a 2y from both sides. Now, in the same step, let's get rid of this x. So if I want to move this over here to the right, I got to add it. So here's the equal sign, and I got x plus y. All right, it's just basic algebra. I just went through it kind of quick. Now we got to solve for y. So I got a y here and a y here. We're going to factor out a y and find out what's left. If I factor out a y from this, I get x minus 2, and that equals x plus 1. All right, let me just double check, okay? And then what I need to do is get y by itself, so I divide by an x minus 2. So y equals x plus 1 over x minus 2. That is our inverse. So I could write it like this. The inverse function of x is equal to x plus 1 over x minus 2, right? So let me grab that other one and put it down here next to it so we remember what it is. It's 2x plus 1. We'll just grab it. Put it down here. All right, scooch that over here. I've always put the function first, so let's kind of scoot this over so you don't get confused. And then, oops, daisy. Go on. There we go. So we want to find the domain and range. Well, we do know a couple things about this. Okay, we know definitely something about the denominator. Okay, we know that x cannot equal what? It's 1. Remember, the denominator can't be 0. So if I make x equal to 1, 1 minus 1 would be 0. So x cannot equal 1 because that would make the denominator 0. So let's come over here. Let's figure out what our denominator cannot be over here. Well, if I made x into a 2, 2 minus 2 is 0. We can't have that. So x cannot equal 2. All right, let me just show you that. And if I can remember, let's see. Yeah, let's graph this thing. Now, this thing right here is going to be a lot harder to graph than what we graphed earlier. So what I'm going to do is I'm going to cheat a little bit, and I am going to do it on a graphing calculator, or in this case, this graph right here. So I'm going to put y equals, let's see what our function was, 2x plus 1. I'm going to put that in parentheses. So I'm going to put 2x plus 1. Forget what the graph's doing right now because we still got a long ways to go. And then I'm going to put divided by, yep, and then put parentheses, and then x minus 1. X minus 1. Now look at that easy graph. What in the world's going on? All right, but this is our graph. It's pretty weird looking. Maybe you haven't seen a graph like that before, but that's what an inverse graph looks like, or a fraction type of graph looks like, okay? It's got actually 2 parts to it. But if you look at it, do you remember we said that x can't equal 1? Well, let's check the graph out. If you really, really blew this up, okay, and we're able to go way, way up here, you're going to find that this line gets closer and closer and closer and closer to 1. This line right here is 1, but it'll never, ever touch it. Well, it can't touch it because if it did, then the denominator would be 0, all right? So that's pretty interesting right here. Same thing with this bottom part. This part right here gets closer and closer and closer to 1 as it goes down, but it never touches it. So really, we can use any single number for our domain and for our range. Actually, our range just keeps on going forever up and down. So our range would be negative infinity to positive infinity. Our domain are all the real numbers except for positive 1. All right, and we kind of found that already by doing this. Let's graph this one, and then we'll just be about done. So let's graph another one. Try to do it quick. Y equals, and what was our 2x plus, let's see. Let's go back to this and look. I got a terrible memory. I can't remember what it is. X plus 1 over x plus 2. That should be easy to remember. X plus 1, let's put it in parentheses. So it's x plus 1 over, oops, I didn't want to do that. I want to do this. So I'm going to put a divide. Divided by, what did I say, x plus 2? Minus 2? Man, told you my memory was terrible. X minus 2. Whew. Don't get old. That's my suggestion to you. X. Okay, so it's x minus 2. There we go. All right, check out that one. That's the blue one. All right, that's your inverse graph right there. And let's do one more. Let's just put y equals x just to show you. See that green line right there? That's your y equals x. Remember, these are symmetric about that green line. And if you look at it, this point and this point are basically mirror images of each other, and you just keep on going. So those are mirror images of each other, and that's what the graph looks like. Now, if you look at the blue one will get really close to where? To 2. Do you see that? See that blue line gets really, really, really close to 2, but it never touches it. And the same, whoops, the same down here. This blue line, right, there's 2, and it gets really, really, really close, but it never, ever, ever touches it. It gets super close, but it never touches. So that's what your domain and range is, okay? Whew, that was a lot of stuff, wasn't it? Okay, so your domain, we're going to write it like this. For the function. So the domain is all the real numbers. Sometimes we write it like this. X such that x cannot equal 1. What that means all the domain are all the real numbers except for 1. That's basically what that means. Okay. And then the range for that one, let me see. Did it? Yep, so the domain of that tell you what, let's just do this. For right now, I need to relook at this just a second, okay? And I don't have enough time. So let's do this. Let's not worry tonight about finding the domain and range. We'll talk more about that tomorrow, whether it's online or in class, okay? But I do want you to be able to find the inverse. So how do you do that? You reverse the x and the y, you solve for y, rewrite it as an inverse function, and that's all you're going to have to do. So don't worry about the domain and range. I think we need to take a whole class period just to talk about the domain and range because I'm just running out of time. So let's see. Here we are right there. Anybody still with me? Wow. Can't believe you all stuck around. Okay, so that's our lesson, and let me give you some homework to do. We're going to do 41 to 55 odd. All right. So now this is the actual book page number. It's 420, 421, and we're going to do 41 to 55 now, and just the odds. Your book, if you use the book, the online book, it's going to be a different page number. I believe. Don't quote me on this, but because I went through this real quick before you guys showed up. It's page 433, and it's numbers 55 to 65. And then just the odds. So this is the online version, and this one right here is the regular version. Okay? I'll put this on YouTube. Check the team's page to find it. If you need to look at any of this stuff again, if you need to see what this assignment is, I'll put it up there. So this is the online, this is the real one, and that's it. We're out of time. Everybody good? Yeah. All right. So we'll see you tomorrow, whether it's online or it's in school, and get this homework done, and we'll look at it tomorrow in class. See ya.
Bye, Mr. Hamrick.
Bye-bye.